So last section for this week, we're going to take a look at is 2.3. Just a reminder while I'm thinking of it, there is a study guide on Schoology for the test tomorrow. So I basically looked at the test and I picked similar problems, but I changed the numbers. So if you want to do that study guide, I will give you 6 points extra credit on tomorrow's test. But the study guide is optional. You don't have to do the study guide. There will be a regular homework assignment though. But the study guide is optional if you want to use it. Do it. If you do it, you can use it on the test. Okay, so that might be something that could help you. All right, so just a reminder, you don't have to write this part down. The multiplication property of equality says that if you have an equation, like, let's say x divided by 3 equals 5, you are allowed to multiply both sides of an equation by the same number. In this case, what would you multiply both sides by to solve for x? Yeah? 3. 3. And then you have a 3 in the top, a 3 in the bottom. And then you get your answer, x equals 5 times 3. So in that case, we use the multiplication property of equality, and we multiplied both sides by the number 3. There's only one number you can't multiply both sides by. Does anybody remember what number you can't? Yeah?
1 or 0?
0. Yeah, you can't multiply both sides by 0, and that's still going to be true today. You can never do that, because if you do that, multiplying by 0 kind of wipes everything out. You won't have anything left. All right, so that was the multiplication property of equality. And now we're going to try to extend that same idea to inequalities, and we're going to see if it works exactly the same. Right? Maybe it does work exactly the same, maybe it's a little different. Let's see. So you guys have a table, and on the table it has an original inequality that is true. Right? Let's make sure everybody agrees. Does everyone agree 3 is less than 4?
Yes.
Okay, so we're starting with something that's true. And what I want you to do is multiply both sides of that by 5. I want to do times 5 times 5. And I want to know what I get when I do that. So if you multiply the left side by 5, Eric, what do you get?
You get 15.
15.
8 plus 10, 20.
You get 15, and then on the right side, 4 times 5 is 20. So we multiplied both sides by 5, and do we think that's still true?
Yes.
Yeah, okay, so that's good. Multiplying both sides by 5 gave us a statement that's true. Okay. So the point is, if you do something on both sides, and it started as true, it should always end as true. If it doesn't end as true, that's a problem. Okay? Because you can't start with something that's true, do the same thing on both sides, and then all of a sudden it's false. That shouldn't happen. If it does, we're going to have to fix it. Yeah.
What do you mean by it's true or false?
So 15 is less than 20. That is true.
Oh, I see.
That is true. It's smaller than the number 20. All right, let's try this. Let's try negative 4 is greater than negative 20. Is that true?
Yes.
Yeah, negative 4 is a bigger number than negative 20. The further to the right on the number line, the bigger it is. And negative 4 is further to the right. Now, it says I want to divide each side by what?
2.
Okay, so we're going to divide by 2. Divide by 2. How about, Molly, if I divide each side by 2, what do I get on the left?
-2.
I get negative 2. I've got my greater than symbol. And Marie, what's negative 20 divided by 2?
-10.
Negative 10. Okay. That's the new inequality that we end up with. Is negative 2 bigger than negative 10?
Yes.
Yeah, it is. Yeah, negative 2 is further to the right. So that's true. Okay, so that's good. We started with something that was true. We did exactly the same thing on both sides, and it was still true. That's what should always happen. Let's try this one. negative 5 is less than negative 3.
False.
True.
That's false.
Number 3.
Yeah, negative 5. You don't think negative 5 is less than negative 3? Like if you think of it on a number line. Here's 0.
Oh, that's positive.
So here's negative 5. And then here's negative 3. Is negative 5 less than negative 3?
Oh, that was positive 5, yeah.
Yeah, negative 5 because it's to the left. So negative 5 is definitely, it is less than negative 3. So that is true. Does everyone agree with that? Okay. Now it says to multiply each side by negative 1. So we're going to do times negative 1 times negative 1. And let's see what happens. Okay. What do you get on the left side if you multiply by negative 1?
5.
You get 5. We've got our less than symbol. And what do you get on the right side if you multiply by negative 1?
3.
3.
That's
Is 5 less than 3?
no.
No. Did we do anything wrong by multiplying, like, did we do it correctly? Negative 5 times negative 1, negative 3 times negative 1? So we didn't make a mistake. We did the arithmetic right, but we ended up with something now that was false. That's not good. We started with something that was true. We correctly did the same thing on both sides, and all of a sudden it turned into something that's false. We don't want that to happen, so we need to talk about what happened there. Let's try this one. 18 is greater than negative 6.
True.
That is true. What do they want me to do on each side this time?
Divide by 3.
Right,
Negative
divide by negative 3. Okay, so let's put our symbol. That's exactly the same symbol we started with. What's 18 divided by negative 3?
Negative 6.
Negative 6. And what's negative 6 divided by negative 3?
Negative 2.
Positive 2.
Positive 2.
What's in there?
Negative 6 is bigger than 2. Is that true? What do you think? That's false. Negative 6 is not bigger than negative 2. Negative number is never bigger than a positive number. So that's also false. Okay. Did we make a mistake when we divided by negative 3, or did we do it okay?
You did okay.
Yeah, we did it okay. We did it right. So we started with something that was true. We did exactly the same thing on both sides, and all of a sudden it made it false. That's not good. Does anybody notice why it worked on the first two, doing the same thing on both sides, but then it didn't work in the second two?
They're both multiple. They're multiple. What's it called again? Like where they both can multiply by the same number. As in 15 and 20 can multiply by 5, and then 10 can multiply by 2. But then if you do the last two, you can't do that. Multiples.
Oh, multiples of them? Well, 3 is a multiple of both 18 and 6, though. Like 3 goes into both of those. Yeah?
The ones that are true are positive.
What do you mean they're positive? I see some negatives in those ones right here, though.
No, the ones you divide and multiply.
Oh, the ones I divide and multiply by, yes. So when you multiply or divide by a positive number, it works fine. When you multiply or divide by a negative number, it doesn't work fine. So we're going to have to remember to do something. Anytime you multiply by a negative or divide by a negative, doesn't matter what the negative is. Negative 3, negative 10, negative 8. Anytime you multiply or divide by a negative, we've got to do something to fix it so that it remains true. Right? And that's what we're gonna look at right now. Okay, so that's what we just pointed out. Okay, from the table, we noticed that if you multiply or divide each side of the inequality by a positive, it worked fine. Right? We got a true statement. But when we multiplied by a negative, what kind of statement did we get?
False.
We got a false statement. Okay. You don't have to write that down. That's just what we realized from the table. Well, we can't get a false statement. We got to keep it true somehow. So, how are we going to do that?
Change the number.
Well, we can't change the number because sometimes the number you have to use to solve the inequality is the number you have to use to solve it. So you just have to use that number. But there's something else we can do.
Change the sign.
Change the sign, right? We can flip the sign. So when we multiply or divide by a negative, we're going to have to remember to do something. And that's what you're going to write down under the if. So you guys already have this first part. Multiplying both sides of an inequality by a positive produces an equivalent, or it's a true inequality. You guys get that part? Okay. Now, if it's a positive, it works fine. If you multiply both sides by a negative, it doesn't work fine. So how are we going to make it work? We're going to flip the inequality. But that's only for a negative. Only if you multiply or divide by a negative. If you multiply or divide by a positive, don't flip anything. Positive works fine. Okay, it's the negative that doesn't. And I didn't tell you this rule yesterday because you didn't need to know it. When you're doing adding and subtracting, you never have to worry about any kind of flipping. That never happens. It's only with multiplying and dividing, and that's what we're doing today. Okay, so what does flip mean to do? Well, if it was a less than, then when you flip it, it becomes a greater than. Right? If it was a less than or equal to, and you flip it, it becomes a greater than or equal to. Right? You just literally make it just point the other way. Right? And we're going to have pretty much the same exact thing for division. I could just really change this word to if we divide both sides by a negative instead of multiply. It's going to be the same thing. Okay, I think you already have the first part. Dividing each side of an inequality by a positive number results in an equivalent inequality, or that means it's true. You guys already have that first part printed? Mm-hmm. Okay. So now you need the if. So where it says if, you're going to put in, we divide both sides by a negative, we need to, what do you think we need to do? Yeah?
Flip the inequality.
Yep, we need to flip the inequality sign. So if you divide both sides by a negative, you need to flip the inequality sign. Now, we did talk a little bit about flipping yesterday, but the only reason we flipped the inequality yesterday is if the letter and the number were on the wrong side. We always want the letter on what side? The left, right? That's totally different. Okay, if you want to fix an inequality at the end because the letter and number is on the wrong side, that's a separate thing that you flip the inequality. This has to do with dividing and multiplying by a negative. Okay, so as far as explaining the process and what we need to do, that's pretty much it. All right, so now I'll let you guys try some examples. All right, I think we have enough time. We probably let you try all of them. And we'll walk around and check in if you have questions. We'll help you out. Does everybody have the if part right there? Okay. All right. So it says to solve and graph. You pretty much know to graph it. If they give you a number line, they want you to graph it. Okay. So solve and graph. 7x is less than 56. Okay, so see if you can solve it. When you think you have the answer and you've graphed it, call one of us over and we'll check in and see if you got it right. All right, well, let's take a look. So this is a one-step problem. You only got to do one thing to get x by itself. What's preventing the x from being alone right now?
7.
The 7. So we've got to do something to get rid of the 7. Right now, it's 7 times x. What operation gets rid of times? Division. And Lily, what would we divide by?
7.
Yeah, we would divide by 7. So divide by 7. Divide by 7. What's 7 divided by 7? And you get 1. Yep. 7 divided by 7 is 1. And now you're just left with 1x, which we normally just write x. What's 56 divided by 7?
8.
That's 8. Now we have to decide what we should do with the symbol. Should we leave it or should we flip it? Leave it? Why not? Why not flip it?
Because it was pointing at the x.
Well, it's pointing at the x, but there's a rule that we have to flip it sometimes.
Yeah, but it doesn't apply there.
Why doesn't it apply here?
Isn't that a double or negative?
Because we didn't divide by a negative, exactly. We divided by a positive 7. We did not divide by a negative, so we don't flip it. If you flip it, now you just made it wrong. So in this case, you do not flip it. Perfect. So x is less than 8. All right, let's make our number line. How about, Madeline, what kind of circle do we need on 8?
Open.
Yep, open. And Evelyn, which way am I going to shade?
To the left.
Yeah, you're going to shade everything to the left. And that's it. That's how you do that one. Any question on that one? All right, so that was 1A. Let's try 1B. Negative 3x is greater than or equal to negative 21. Okay, so we'll give you guys a couple minutes to try that one. And then once you think you get it, just call us over and we'll take a look. So this is negative 3x is greater than or equal to negative 21. Okay. Is the x by itself?
No.
No. What's preventing it from being alone?
Negative 3.
Negative 3. And right now it's negative 3 times the x. So what operation do we have to use on both sides? Yep. We're going to divide. And we're going to divide. And what are we going to divide by? Negative 3 and negative 3. What's negative 3 divided by negative 3? 1. So that's gone. That cancels out. And what's on the left-hand side now? Yep, just x. And what about negative 21 divided by negative 3?
7.
Yeah, negatives are going to cancel. You get 7. Now, what about the sign?
You have to flip it.
You have to flip it. Why?
You divided by a negative.
Because we divided by a negative. So when we say flip the inequality, I should be a little clearer on that. You're just taking this and flipping it. So now it's going to point that way. If you don't flip the sign when you divide by a negative, it's going to give you the wrong answer. Okay, so that is what you should have for your inequality. Any questions on that? Yeah.
What if x were 6?
What if x was 6?
Yeah.
6 would make that statement true. Like if you had to check if 6 was a solution to this problem, which you actually are going to have some of those on the test, yes or no, I would say yes. 6 is a solution.
But wouldn't the sign make it false?
Nope, because if you fill in a 6 right here, is 6 less than or equal to 7?
Oh, wait. What if it were 8?
Then I would say that would be false. I would say that is not a solution to this problem. So you'd click no. Some numbers are solutions, some numbers are not solutions. We're going to graph what the numbers are solutions right now. So on our number line, what kind of circle do we need? Closed on what number? 7. And which way do we shade? To the left. So any number that you ask, if it's in the red section, I would say yes, it's a solution. Any number that's not in the red section, like 8, I would say no, it's not a solution. If you didn't flip this sign, you'd have everything backwards. It would be backwards. So you've got to remember when you divide by a negative to flip that sign. Any question on that one? All right, let's try. Okay, let's try this one. So example 2a, x divided by 2 is less than 5. Okay, so see if you can solve it, graph it, and then we'll check in and see how you did. So x divided by 2 is less than 5. Is the x by itself?
No.
Nope. What's there that we don't want? So the 2, and right now the x is being divided by the 2. So how do we get rid of divided?
Multiply
We multiply,
by 2.
and we multiply by 2. All right. When you have 2 and then divided by 2, what happens there?
Yeah.
Yep, that gives you 1. So those are gone. We get x. What's 5 times 2? 10. And now we're going to think about the symbol.
Flip it.
Why would we flip it?
Because you flip the, what's this called, the fraction. Flip the reciprocal fraction.
We didn't divide by
But you didn't
Yeah, we
divide
didn't
by
divide by any negatives.
So yeah, the rule for flipping it is if you were to multiply by a negative.
Oh, so it's the same.
It stays the same because all we did was multiply by positive 2. Yep. If the letter was on the wrong side, then we can fix it. That's a whole other reason for flipping it. That has nothing to do with what we learned today. That's just fixing it so the letter's on the left. Okay, but in this case, we multiply by positive, and we're good. So now, we have to make our number line. Let's just go like this. Good enough. What kind of circle do I need this time?
Open and pointing to the left.
Okay, open and where? Open circle on
10.
10. And it's going to point to the left. Perfect. So any number that's in the red section, if you plug it in, it would be true. Any number that's not in the red section, if you plug it in, would be false. It would be the wrong answer. Okay. Any question on 2A? All right, try 2B. And then we'll do the word problem together. Okay, so 12 is less than or equal to x divided by negative 3. Is the x by itself?
No.
Nope. What do we have to get rid of to make it by itself?
Negative.
We got to get rid of the negative 3. And what operation do you use on both sides?
Multiplication.
Multiplication. So we're going to multiply each side by what number?
Negative 3.
Negative 3. So times negative 3 times negative 3. What happens when you have divided by negative 3 times negative
They would
3?
cancel out.
They cancel out. So that's gone. What's on the right-hand side? Just the x. Now the left-hand side, what's negative 3 times 12?
Negative 36.
Negative 36. Now we have to decide what to do with that. Keep it or flip it?
Flip it.
Flip it. Why?
Because you're multiplying with negative.
Multiply by a negative. Now, that answer, it's technically correct.
But
Right.
then you have to flip it again, so then it's Letter, symbol, number.
Right, that's more of like a formatting thing. We like to write it letter, symbol, number, so then this tells us which way to shade, all right? So if you wrote that in the box on the test, it would be marked right. But in order to have it help us know which way to shade, because if you think you're shading to the right in this problem, that is wrong. You're not shading to the right because it's not set up letter, symbol, number. Okay, what's my letter in this problem?
X.
What's my number?
Negative 36.
And what's it pointing at in the original?
It's
pointing.
right.
It's pointing at the X. So it's still, when you fix it, has to be pointing at the X. So that rule for flipping it is just to fix the format of how it looks. That's a different rule than dividing by a negative or multiplying by a negative. They're totally separate things. Any question on that? Okay. Now, the reason we do that, well, there's lots of reasons. Usually in math, all the time, we try to get the letter on the left. Like when we start doing equations, graphing them, we're going to have the letter alone on the left. It's called y equals mx plus b. So it's just kind of a good habit to get into getting the letter by itself on the left. All right. We need to make a number line. What kind of circle do I need? Yep, I'm going to need a closed circle. Yeah, I'm just going to number it like that.
On the 36.
Closed on the
36. Negative 36.
negative 36.
Going into the close.
And we're going to shade everything that's smaller than negative 36. And that's 2b. Any question on that one? All right, so the last one. Let's look at the word problem. I think you guys already have it. Make sure the numbers are the same. 9.5, 247. Yep, looks good. Okay, so it says that you earn $9.50 an hour. Write and solve an inequality that represents how many hours you need to work to buy a digital camera that costs $247. Okay. So, how much money do you need to have to buy the camera?
20%.
247 or
More.
right? You could have more than that.
Should be greater than or equal to.
Yep. So the amount of money that you need to be able to afford this camera has to be greater than or equal to 247. Now what we need to do, we have to figure out a formula that represents how much money you have. You make $9.50 for every hour you work. All right, well, first thing we should do is pick a variable that represents how many hours you work during the summer. We don't know how many, so we'll pick a variable. Yeah.
H.
Okay, so we're going to use H. And if you make $9.50 an hour and you work that many hours, what do you do with the number of hours you work and how much money you make per hour to figure out your total?
Divide.
I mean, not the answer.
Divide. What's that?
So like, if let's say you make it simple, you
Right.
make $10 an hour and you work 2 hours, how much money would you make?
20.
20. So what did you do with the 10 and 2?
Multiply.
You multiply, yeah.
So.
So, take how much money you make per hour times how many hours you work, and that has to be greater than or equal to the amount of money you want to get to afford the camera. All right, so take a minute or two and see if you can solve that one. You might need a calculator to figure that one out. All right, so when you get it, let me come out. I'll come check what. All right, so let's finish this one up. Okay, H isn't by itself, so we have to get it alone. What number is next to H that we don't want?
950.
The 9.50, yeah, we got to get rid of that. And what operation do you do on both sides to get rid of it?
Divide.
Yeah, divide. And what would you divide by?
90.
9.50. If you do 9.5, is that the same thing?
Yeah.
Yes.
It's the same thing. We just put the 0 because we're dealing with money. That's all. Now, when you do that on Edge Elastic, I usually make available the calculator. I think it's right up next to the bookmark button. So if you click that, you get a calculator right on the screen that you can use and type it in. But if you're in my room while you're taking the test, I also have those calculators up front, so you can use those. All right, let's type it in. So we got 247 divided by 9.50 gives me 26. So I got 26. What's on the left-hand side? H. And I kind of assumed it. I didn't really ask you this time. I didn't flip the inequality. How come I didn't flip it?
Because we're not dealing with any negative.
Yeah, I didn't divide by a negative. So as long as you work greater than or equal to 26 hours, you will have enough money to afford the cash. All right. So let me put up the homework. Is the 2.3 worksheet. The extra credit is the 2.1 to 2.3 review. Okay, so the extra credit, that is optional. The homework I will check tomorrow. I'll be after school today. If anybody wants to come by, if they have any questions, they want to check in. And then we have our test tomorrow.